Welcome to the deep dive. Today we're grabbing a big stack of source material and plunging into the world of cloud computing, specifically Amazon Web Services or AWS. Our listeners shared some really fantastic stuff that gives us a roadmap across several key AWS services: Elastic Compute Cloud, that's EC2, Elastic Block Store, or EBS, and it even mentions others like VMware Cloud on AWS, AWS Batch, Outpost, and Lightsail.
That's right. And, the sources offer a great overview of that whole landscape, but they really dig deep into EC2 specifically. We get a lot on instances, their life cycle, and all the, fascinating ways you can buy and manage them. So I think we should concentrate on extracting those core nuggets, right? Give you a crystal clear picture of what's covered there, and then maybe touch on the others to complete the view.
Okay, sounds like a plan. Let's unpack this and see how we can help you visualize these powerful tools and, understand what they mean for actually building things in the cloud. Let's start with the heart of it then. EC2 instances themselves. So these are basically your virtual computers running in AWS. But it's not just one type of virtual computer, is it?
Not at all, no. The sources really emphasize that EC2 instances come in different families, and each one is optimized for specific types of work. It's like you wouldn't use the same vehicle for every single job, right?
Exactly. Like you've got general purpose ones for maybe everyday jobs like web servers.
Right.
Then compute optimized for the heavy processing stuff.
Yep, and memory optimized for things needing lots of RAM, storage optimized for big data systems, Hadoop clusters, NoSQL databases, that sort of thing.
And accelerated computing, what's that for?
That's for the specialized tasks, things needing GPUs or other hardware accelerators. Think genomics, financial modeling, graphics rendering.
Gotcha. That vehicle analogy really works. The sources even mention how the names give you clues, like M for large.
Exactly. The M tells you it's general purpose. 4 is the generation. Newer usually means faster, better. And large is the size within that family. It tells you about its compute, memory, storage capacity. It's like decoding the model number.
Okay, so you pick the right tool for the job.
Yeah.
Now, these virtual machines, they aren't static. They go through different phases, a life cycle, right?
They absolutely do. And understanding this is, it's crucial, especially when you think about cost. Instances move through states like pending, running, rebooting, shutting down, terminated, stopping, and stopped. You can almost picture them, spinning up, doing work, winding down.
And the big question, which of those states are you actually paying for the compute time?
Right. The sources make this very clear. You are primarily billed when the instance is in the running state. That's the main one. If it's rebooting, it's still considered running. So, yep, you're billed then too. Now, interestingly, you are also billed if it's in the stopping state, only if you've configured it for a feature called Stop Hibernate.
Oh, okay.
In all the other states, pending, shutting down, terminated, or just a regular stop state, you are generally not billed for the instance's compute capacity itself.
That difference between regular stopped and stop hibernate seems pretty important for costs then. Hitting stop usually turns the meter off unless you use that specific hibernate feature.
Exactly. And speaking of hibernate, the sources describe it quite nicely as a freeze state.
A freeze state, so like putting your laptop to sleep instead of shutting it down completely?
Precisely that, yeah. But for your cloud server. When you hibernate an EC2 instance, AWS saves the contents of the instance's RAM right onto its root EBS volume. So what gets preserved? Well, the RAM contents, the instance ID stays the same, the running processes, private IPs, and importantly, the EBS root volume and any data volumes attached.
And the big benefit the sources mention is using it to pre-warm applications, like ones that take ages to start up.
Yes, exactly. You launch the instance, get your app running and all configured, then just hibernate it. When you start it again later, it just resumes right from where it left off. Much, much faster than a cold boot.
Makes sense. And billing in that frozen state.
The sources are explicit. You are not billed for the instance's compute time while it's in the stopped hibernate state.
Okay.
But, and this is key, you are still billed for the associated EBS volumes, because that's where the RAM content is saved. And potentially for any Elastic IPs attached to. So compute cost pauses, storage cost continues.
Okay, let's switch gears a bit. Let's get maybe a little more technical. CPU options. The sources talk about optimizing how you use the CPUs on your instances.
They do, yeah. It ties into multi-threading. Most modern CPUs can run multiple threads at the same time in a single core. AWS represents each of these threads as a vCPU on your instance. So one physical core might show up as, say, two vCPUs if multi-threading is turned on.
So a single physical core can look like multiple CPUs to the OS because of this multi-threading.
Exactly. A vCPU is typically one thread of a core. The sources do note the older T2 instances were an exception, but generally that's the idea. And the sources point out you can optimize this. You can actually choose the number of CPU cores that are visible to the instance.
But why would you want to limit the cores if they're physically there? Seems counterintuitive.
One big reason the sources mention is software licensing. Some software is licensed per CPU core, and it can be expensive.
Ah, right.
So by controlling the number of cores the instance reports, you could potentially cut down those licensing costs, even if the hardware underneath has more available. Another optimization is disabling multi-threading altogether, setting it to just one thread per core. The sources point out that high-performance computing, HPC applications, often benefit from this. For some really tightly coupled parallel tasks, getting rid of the overhead of threads switching on the same core can actually boost performance.
Huh. That's really interesting control. So you can tweak the virtual hardware for licensing or for specific performance needs. That example they give, the T3.X large having 2 cores but 4 vCPUs by default, that helps visualize it.
Yeah, it shows that one physical core to 2 vCPU mapping pretty clearly.
Okay, so you've picked your instance, maybe tweaked the CPUs. How do you get it set up automatically when it launches? The sources mentioned user data.
Right. Instance user data is basically a script or just a block of text that you provide when you launch an instance. It's a way to pass instructions to the instance that get executed the very first time it boots up.
Right, telling it what software to install or maybe which config files to download or how to join a domain, stuff like that, right, when it comes alive.
Exactly. It's a really powerful tool for automating that initial setup. The sources do note there's a size limit, though 16 KB. So it's meant for bootstrap scripts, not for embedding huge amounts of data.
And what if you need to change that script after the instance is already running?
For EBS-backed instances, the sources say you have to stop the instance first. Then you can modify the user data. The instance essentially needs to be, rebooted with the new instructions for them to run on the next start.
All right. That covers getting instances up and initially configured. Now, maybe one of the most complex but really impactful areas, how you actually pay for these things. The sources detail several purchasing and launch options. This is where you can find some serious cost savings, right? If you choose carefully.
Absolutely. This is critical for managing your cloud spend. The default, and usually the most expensive option, is on demand. You pay by the second for Linux instances, or by the hour for others. It gives you total flexibility launch when you need, stop when you don't. It's perfect for unpredictable workloads, short-term jobs, or anything that simply cannot be interrupted.
Okay, on demand is the standard pay-as-you-go. What else is there?
The sources mention on-demand instances, capacity reservation. This is a bit different. It lets you reserve a specific amount of on-demand capacity in a particular availability zone. Now, you pay for this reserved capacity whether you launch instances into it or not.
Oh, okay.
But it guarantees the capacity is available for you when you need it. It doesn't give you a discount by itself, but it can work with reserved instances or savings plans. Think of it like booking a specific parking spot you pay for the guarantee.
Right. Speaking of reserved instances, Rise.
Yep, Rise offer big savings. The sources say up to 75% off on-demand prices. The catch is you commit to a 1 or 3 year term. They could be scoped to a specific availability zone that's zonal, which gives you both a price discount and a capacity reservation. Or they can be regional, giving you just the price discount, but more flexibility on which AZ you use within the region.
And there are different types of RIs.
Yes. The sources distinguish between standard IIs and convertible RIs. Standard IIs have the highest discount but are less flexible. You can generally only change the instance size within the same family and region. Convertible RIs offer a slightly lower discount, maybe up to 54%, but they're much more flexible. You can actually exchange them for other convertible RIs, different families, OS, tenancy, the works.
And you can even sell standard RIs on the AWS marketplace.
That's what the sources mention, yeah. If your needs change dramatically, there's potentially an outlet.
Okay, RIs seem great for stable workloads where you can commit. How do savings plans compare? Are they different?
Savings plans are presented as a more flexible way to save, again with those 1 or 3 year commitments. But instead of committing to specific instance configurations, like with Rise, family size, you commit to a consistent amount of compute usage, measured in dollars per hour. This flexibility can get you savings up to 72%.
Okay, so it's a commitment to spend rather than a specific instance type.
Exactly. And there are two types detailed in the sources. First, compute savings plans. These offer up to 66% savings, and they apply automatically across any EC2 instance. Usage doesn't matter the region, family, size, OS, or tenancy. They even apply to usage in other compute services like AWS Fargate or Lambda. Very broad.
Wow, that's flexible.
Then there are EC2 instant savings plans. These offer higher savings up to 72%, but they only apply to usage within a specific EC2 instance family in a chosen region. You still get flexibility within that family. You can change size, OS, or tenancy, but you're committing to, say, the M5 family in its next week.
Got it. So savings plans, especially the compute plan, offer more flexibility if your usage might shift around different instance types or even services. What about cases where you need dedicated hardware, like really need it?
That brings us to dedicated hosts and dedicated instances. A dedicated host means you're essentially renting an entire physical server from AWS. You pay for the whole box. This gives you visibility into the underlying hardware cores, sockets. It's often needed for bring your own license, BYOL scenarios, where software licensing is tied to physical hardware.
Or maybe compliance reasons?
Exactly. Company policy or regulations that just don't allow sharing physical hosts with any other customers. Dedicated hosts can be shared across accounts within your own AWS organization, though. Billing is either on demand or reserved for the host. It's like having your own server rack in their data center.
Okay, and dedicated instances, how are they different?
Dedicated instances are EC2 instances launched on hardware that's dedicated to your account. So your instance won't share a physical host with instances from other AWS accounts. However, the sources make a point here. They can share hardware with other non-dedicated instances from your own account. So it's isolation from other customers, but not necessarily total isolation from your own stuff on that same physical machine. You pay by the hour for the instance running on that dedicated hardware.
Okay, that's a really comprehensive set of options. Flexibility, commitment savings, hardware control. Now let's hit the one that sounds cheapest, but maybe riskiest. Spot instances. The sources kept saying they're interruptible.
That's the absolute key characteristic, yes. Spot instances let you bid on unused EC2 capacity in the AWS cloud. You can get them at massive discounts compared to on-demand. But the catch is, AWS can reclaim that capacity, terminating your instance with just a 2-minute warning if they need it back for on-demand or reserve customers.
So definitely not for everything.
Absolutely not. The sources are really clear. Spot is best for workloads that are stateless, fault-tolerant, or just generally flexible enough to handle being interrupted. Think batch processing, data analysis jobs that can easily restart from a checkpoint, background tasks, optional rendering jobs. They explicitly say do not use Spot for mission-critical production databases or anything that just cannot tolerate interruption. It's like flying standby. Like you said, super cheap, but you might get bumped.
Given that risk, how do you manage them effectively? Is there a strategy?
Yeah, the sources suggest a common approach. Build a baseline of stable capacity using on-demand, maybe with IIs or savings plans for cost efficiency. Then, use Spot instances to scale out or handle the parts of your workload that can tolerate interruption, taking advantage of the lower cost when capacity is available. You make a Spot request specifying what you need, your price limits, etc.
And there were different request types.
Right. One time it tries to fulfill your request, and once it does, or expires, or you cancel, it's done. And persistent this type tries to maintain your target capacity, relaunching instances if they get interrupted, until the request expires or you cancel it.
Okay, interruption is the big risk. How does AWS actually let you know it's coming?
So by default, when AWS needs the capacity, the instance just gets terminated after that 2-minute warning. However, for supported EBS-backed instances, the sources mention you can configure the interruption behavior. Instead of terminating, you can have it stop or even hibernate the instance.
Hibernate again.
Yeah, so you could potentially save the state and resume later. You get that 2-minute warning notice either through the instance metadata service or via an EventBridge event. There's another helpful feature mentioned, the Spot instance rebalance recommendation.
Rebalance recommendation.
Yeah, it's a signal, also sent via EventBridge, but it comes before the standard 2-minute interruption notice. It tells you that a specific Spot instance is at an elevated risk of being interrupted soon. This gives you, or more likely an automated system like auto-scaling or EC2 fleet, more time to proactively launch a replacement instance before the official interruption actually happens. It helps smooth things out.
That sounds really useful for managing the risk. Now, the sources mentioned Spot Fleet and EC2 Fleet. Are they the same or what's different?
They're related, but EC2 Fleet is presented as kind of the next generation, the more modern approach.
Yeah.
Spot Fleet came first. It let you request a collection of spot instances, potentially mixing in some on-demand across different instance types and availability zones. It would try to maintain a target capacity, pulling from the cheapest spot pools that met your specs. You could often manage this through the AWS console. EC2 Fleet, introduced later, is broader. It lets you launch a fleet using any purchasing option, on-demand, RIs, and spot across multiple instance types and AZs, all within a single API call. It's more flexible. It can factor in your existing RIs or capacity reservations for cost optimization, and you can specify separate target capacities for on-demand and spot within the same fleet request.
And you manage it differently.
Primarily, yeah.
Yeah.
While Spot Fleet had console options, EC2 Fleet is mainly driven via the CLI, SDKs, or direct API calls. It's more powerful, more integrated with all the purchasing options.
So EC2 Fleet is like the super-powered version, mixing and matching everything, while Spot Fleet was more focused just on getting cheap spot capacity.
That's a good way to put it. The sources also quickly mentioned allocation strategies, which apply here too. Capacity optimized. Aims for stability by picking pools with the most available capacity, not just the cheapest. Lowest price goes for pure cost saving. And diversified spreads instances across different pools to reduce the impact if one pool gets interrupted.
Okay, shifting from how you buy instances to where they physically live inside AWS. Normally, AWS spreads things out for safety, right? The sources say you can control this with placement groups.
Exactly. By default, AWS tries to place your instances on different underlying hardware to minimize the impact if one piece of hardware fails. But sometimes, your application has specific needs, either for performance or availability, that require more control. That's where placement groups come in. The sources detail 3 types.
Okay, what are they aiming for?
First, cluster placement groups. Instances in a cluster group are deliberately placed close together, physically, within a single availability zone. The goal is super low network latency and high network throughput between those instances. Think high-performance computing, HPC, where nodes need to chat very, very quickly. Enhanced networking instances are recommended here.
But the trade-off is?
Availability. Since they're all packed together in one AZ, if that AZ has a problem, your whole cluster is affected. High performance, but concentrated risk.
Okay, what's next?
Second, partition placement groups. This approach spreads your instances across different logical partitions. Think of partitions as groups of racks within an AZ, each with its own network and power. This can span one or more availability zones. It's designed to reduce the chance of correlated hardware failures affecting your application. Ideal for large distributed systems like HDFS, HBase, Cassandra things, where you want data replicas spread across separate hardware failure domains. The sources say up to 7 partitions per AZ.
So spreading out for resilience within or across AZs. And the third type?
Finally, spread placement groups. This gives you the maximum separation. Each instance in a spread group is placed on a completely different underlying rack. This can also span one or more availability zones. There's a limit mentioned 7 instances per availability zone per group. This is best for applications with a small number of absolutely critical instances where you want to minimize the impact of any single hardware failure hitting more than one instance. Think critical infrastructure nodes or maybe an active-passive pair.
Right. So cluster for speed in one AZ, partition for spreading distributed systems across racks, and spread for maximum separation of a few critical instances. That really covers different needs. Can you change an instance's placement group after it's launched?
The sources say yes, you can. You can move an instance into a group, out of a group, or between groups. However, the instance must be in the stop state before you can make that change. You can't just live migrate it into a different placement strategy.
Okay, that makes sense. We've really dug deep into EC2 based on the sources types, lifecycle, cost, placement. The material also briefly mentioned Elastic Block Store, EBS, and pointed to other related services.
That's right. While EC2 got the most detail, the sources laid out the landscape, showing topics related to EBS like its different volume types, snapshots for backup, managing their lifecycle, encryption, sharing snapshots, even using EBS volumes in RAID configurations.
EBS being the persistent storage, the virtual hard drives for EC2.
Exactly. And snapshots are the backups. The sources also listed other services, just outlining them. VMware Cloud on AWS, running VMware on AWS hardware, AWS Batch for batch jobs, AWS Outposts, AWS Infra in your data center, and AWS Lightsail, simplified hosting bundles.
It just highlights that EC2, while fundamental, sits within this much bigger ecosystem of tools and services you can use on AWS.
Yeah, it shows the breadth of what's available once you start building.
Wow. Okay. We really covered a lot of ground today. We went from the basic kinds of EC2 instances and how their life cycle impacts your bill
Uh-huh.
to optimizing CPUs, automating setup with user data, and then navigating that whole complex world of purchasing options on demand, RIs, savings plans, dedicated options, and spot instances and fleets.
And we finished with placement groups. Seeing how you can strategically position your instances for specific performance or availability goals, it really drives home the level of control and flexibility AWS gives you.
It really does feel like a powerful toolkit, doesn't it? You can assemble exactly what you need. Thinking about all these options together, especially the purchasing strategies mixed with placement groups, it really makes you visualize the trade-offs, cost versus performance versus resilience for whatever application you're trying to run.
It absolutely does. And this brings up a really interesting thought, doesn't it? How might creatively combining these different EC2 features, say, using specific instance types optimized for a task, placed within certain placement groups for performance or resilience, and funded by a smart mix of savings plans and maybe some spot capacity? How could that dramatically change both the architecture and the cost profile of a single application? It's definitely something worth exploring further depending on the specific workload you have in mind.
Thank you for joining us today.